Yes, again, welcome to energy, electrical energy um, conservation and energy management lecture. So, up to the last lecture, we discussed the demand side management, and the objective of demand side management is nothing but to reduce the maximum demand, or in short, to make the load curve as flat as possible, and to obtain the fruitful demand side management. Demand side management consists of two part, that is nothing but the demand response. So DSM consists of two major components. That is, one is the demand response, a part of load management where we are going to manage the load, and the load management consists of number of options are there which we have already discussed. And second part is the energy efficiency. So the combination of energy efficiency technology, adopting the energy efficiency technology, and part of the demand response, that is the demand management, we can achieve the demand side management very effectively, isn't it? Now the demand response, where it consists of different options are available there in the demand response. That is, a direct load control is there. It may be a local load control. In the local load control, the consumer is going to control its maximum demand either by peak silping or peak silping and valley filling. We have already covered very deeply the topic peak silping and valley filling. Then it may be a load shedding. Final flexible load shape is there, tariff option in the DSM, and end use energy conservation program. So the energy conservation program is adopted by is may be achieved with the help of energy efficiency technology. So if we are replacing all non-efficient machineries by the efficient, definitely it will reduce the maximum demand, it will reduce the contract demand and connected load, and therefore we can obtain the demand side management very effectively. Okay, so this is the things which we have already covered. Now for the demand response, there is some other methods or to achieve this one DSM. One is the peak silping. We have already covered this topic, but with the help of this diagram, simple diagrams are there. It can be explained very well. Peak silping, here it is shown that this is the load curve. Simple, it is a load curve. Here there is a demand, and here is the time. So on x-axis it is represent the time, and here it will represent the demand over there. So this is the load curve is there. It is not the load curve. Definitely, it is the symbolic representation. Here it means there is a hill, and there is a maximum demand is going to occur, and we want to reduce that maximum demand occurring by peak silping. So reduction of the utility load preliminary during the period of peak demands. So the peak selfing is nothing but the reduction of utility load. It may be the consumer load, it may be the generating power plant load is there, and it is called as a peak selfing. Similarly, the second is the valley filling. So in valley filling, we come to know that this is the peak, this is the hill is there, and this is the valley. And if you are able to fill up the valley, what will it become? The load curve become in this way. So it is somewhat as flat as possible. There is a small peak is there, and whereas we are filling the load. So we are filling the load, the meaning is that your generator is utilizing very effectively, or electrical installation are going to use very effectively. In during night time there is a no load, there is a small load is there, and still we have to run the generator, because uh, consumer want energy, or consumer want electrical supply 24 hours. Utility is bound to supply the energy, isn't it, at any cost, even though their generator is not operating at proper loading condition. And when the generator is not loading condition, definitely it does not give the efficiency, and it means that the generating cost is very high. So we can conclude that in the night time, even though the load on the power plant is small, but the generating cost, the unit rate of electricity is higher one. To utilize that capacity in the night time, if somebody or some of the consumer are consuming energy night time, it will get some benefit. That is the incentive from the MSDCL and from the state electricity board. And the using electrical energy in the night time is nothing but the valley filling. So valley filling is the consuming more energy during off period is called as a valley filling. Okay, so this is the two method to obtain the demand response. One is the peak sleeping, second is the valley filling. Next is the conservation. Conservation, we are doing the conservation, and that conservation is going to affect 24 hours entire on the day or 24 hours, because everywhere there is a reduction in consumption. Suppose it is a factory, we have implemented the energy conservation program, we did the energy conservation. Okay, consumer carried out the exercise of energy audit, energy conservation, whatever the energy efficient equipment has been utilized, all the old machineries has been replaced by the new rated sorry star rating machines are there. So what happened, the total electric consumption of the industry get reduces, maximum demand also reduces, the consumption in the night time also reduces, consumption in the daytime also reduces. So it is the simple representation, this diagram are the representation of the energy conservation. So because of this energy conservation, the load curve that is shifted to the downward. So this is the representation of energy conservation. So the valley filling, improvement of the system load factor by building load in off peak period. Our objective is to maintain the load factor as near to unity, isn't it? In this case, the load factor will be small because the average load, this is the average load, and whereas the maximum demand is very high, and under such condition the load factor is smaller. Okay, here the average load is this much. Okay, this much is the average load. So we found that the difference between average load and maximum demand is very small. The gap is very small, hence the load factor get increases. Okay. So improvement of the system load factor by building up in off-peak period is nothing but the valley filling. Second is the energy conservation. So reduction of utility load everywhere. We are reducing the load in the night time, in the daytime, in the off peak period, in the peak period, more or less equal to the during all or most hour of the day. No doubt it may be happen that because of the say more investment in the replacement of machine, we are not going to replace all the machineries. Definitely we are going to replace the machineries where energy consumption is more, operating time is more, definitely the saving will be more. Say for example, in the college, I have to do the energy conservation in hostel more effectively or very consciously. Why? The reason is that the load is remain on in the daytime as well as in the night time. Okay, the students are using daytime also and night time also. Whereas in the say in a classroom or lab, the lighting load will remain present in the daytime only, but in the night time there is no load at all, isn't it? Even in the daytime also, the load is very small, only some of the season where the natural light is not available, when we are using some uh, light fixtures over there. So the replacement of light become, it does not give the much more reduction in the electric bill for the college. Whereas if you are doing the replacement option in the hostel lighting, it will give the remarkable energy saving. Similarly, the machine which is going to run 24 hours, if I do the replacement of the machine by energy efficient machine or reduction in the losses, definitely it will give the more attractive saving in the replacement option. Whereas the machine which operate only for 2 hours and 3 hours, then the conservation or the saving of amount, saving of energy and saving of money is very small, and it will give the payback period will be very high, isn't it? So what we will do, we will replace the energy efficient machineries where the consumption is more, and the machine which is going to operate for large period of time in hours. So the reduction of utility load more or less equal to equally during all or most of the working day. This represents the flexible load shape. Flexible load shape options to alter the consumer energy consumption on an as needed basis. So as per the need, we can do the load shape, flexible load shape. We have discussed that it is not necessary to run the pumping load in the daytime, so we can shift into the night time. So what we are doing, this is the flexible load is there where we can shift to the off peak period, isn't it? Or we can utilize by other way. So by doing such flexible load shape, it is the representation, and some of the load which is going having the flexible in shape, that is flexible in use, so it can be. Now next is the load shifting. Load shifting is that load silping and load shifting. This is two different terms. Peak silping, peak silping is nothing but we are curtailing the load. We are just switch off the some of the feeders which is not necessary to run, isn't it? But it is necessary to run for the 3 hours or 4 hours, but it can be shifted. So what we are doing, we are shifting the load during the peak hours to the off peak period, is called as a load shifting. Whereas peak silping, we are just reducing the load during the peak hours. Okay. So load shifting, we are shifting the sum of the load which is going to occur, which is going to operate simultaneously in the peak hours. It is into the off peak period. Again, it will give the load curve as flat as possible. So the reduction of loads during period of peak demand with building load in off peak period. So we are shifting the load from the peak hours to the off peak period. So that is called as a load shifting. So do not confuse between peak silping, load shifting and valley filling. Okay. Now in the valley filling, it may occur that we cannot curtail the load during the peak hours, isn't it? And because of this one, your load curve will be, or load factor will be very small. So we have to use the load, we have to say use the some production plant in the night time, such that our load curve become as flat as possible, and we are able to get the benefit of electrical rates or units electricity rate in the night time. Now, when everything is good, we have ample quantity of energy for the from the utility side, then we can do the load building. Means we can increase our demand, we can increase the use of electrical energy without any loss or so. Therefore, it is called as a load building. So, increase of utility load more or less equally during all or most of the hours of a day. So when we are going to build the load, when we are going to increase the load, we should take care that the load should increase 24 hours in a day. It should not occur only the peak hours. Suppose you have done all these things and next time you are going to start some additional units or additional production area. So you are going to operate only in the peak period. No, you have to operate some of the machine in the peak period, some of the machine in off peak period, such that the total load built up will be similar to the uh, conservation load curve is there. Okay. So this is the uh, implementation and how we are going to develop the DSM programs over there. Now implementation, DSM implementation. How we are going to implement this DSM? Because it consists of utility participation, it should be consist of some market participation, manufacturers are there, consumers are there. Okay. So first is the market transformation. What is the market transformation? The market transformation means in the market only energy efficient machinery should be available. For example, when you are going to purchase some electrical gadgets or some geyser heater, we were looking the mark, ISI mark is there. Okay, when there is a ISI mark is there, so we are confirmed that everything is good, quality is good. There is a say it will does not lead to the major accidents, safety to the people, safety to the electrical installation. Similarly, because of the energy crisis there, we are or the consumer are interested to purchase electrical gadgets or electrical machineries which is more efficient, and we are looking the star rating. How much star ratings are there? Either the machine is 2-star rating, 3-star rating, 5-star ratings. So it is found that suppose you are going to purchase a one refrigerators of 160 liters are there, you will find of the same brand, same company manufacturer, same capacity, it is available in 3-star rating, 5-star ratings are there. The cost of 5-star rating is higher and the cost of 3-star and 2-star rating will be smaller, whereas the capacity is same and the manufacturer or the brand name is same, but because of the star rating, higher star rating is more costly. The reason is that whatever the material used is in such a good grade that it will consumes less energy. Okay, so the market transformation is a very important tool to implement the demand side management program. If it is banned, it is banned that nobody is going to sell without star rating pumps, without star rating fans, without star rating refrigerator and ACs are there. Definitely, uh, the market will have only the star rated energy efficient equipments are there. Therefore, consumer is going to purchase only energy efficient, and it will build the demand side management of the second part, that is the energy efficiency. In the demand side management, there is a two part which I already discussed. One is the demand response and second is the energy efficiency technology. So if market ban or government ban all manufacturing and selling of non efficient equipment, definitely it is going to transfer to the energy efficient machineries through the market, and therefore it is called as a market transformation, isn't it? So even though you are going to see that if you are going to purchase the pump for your say it is the farmhouse or somewhere for the agriculture purposes, you found that the motor cost, the pump cost is 8,000 rupees, and the same capacity of a star rating it is at 18,000 rupees. So what is the difference? There is a difference in the energy consumption, there is a difference in the kVA, there is a difference in the working power factor. Okay, and again there is a difference in the discharge level. So you see the details of these two pumps are there. You will find that the pump which have some star rating, the discharge, that is the pump pumped water in per minute or per hours is more as compared to the water pumping or water pumped by the non energy efficient pumps is there. So if you ban, the government get say a restriction over to sell such type of non efficient equipment, definitely it will implemented, it is become too easy for implementation of the demand side management through the market, and this process is called as a market transformation. Second is the energy efficiency labeling. We will provide some energy efficiency labeling as per the test conducted by the BEE. In the BEE labs are there. Some of the labs, international labs are there where we have to test our product. If the product is tested and found okay, as per that one, we are the BEE, Bureau of Energy Efficiency, is awarded some star rating. It may be a 3-star rating, 4-star rating, 5-star rating. So in the market, only star rated machines are available, and it is called as the energy efficiency labelings. So earlier only few electrical gadgets are available with the label with the energy efficiency labeling, like refrigerators and ACs are there, but nowadays you will find every electrical gadgets are labeled with some energy efficiency marking, isn't it, or labelings are there. Even I will give the simple example. If you are going to use some fluorescent lamp in your home or in your office or somewhere, you find that the cost of the fluorescent lamp is hardly 45 to 50 rupees. That is the filament of the fluorescent lamp. Now see the what is the output lumens from that particular filament, particular tube say fitting is there. You will find that it consumes 40 watt or 36 watt, and the lumen output is 1800 lumens, total lumens, gross lumen output by the light source. Whereas energy efficient uh, uh, tube lamp is available. It is rated by 5-star rating and 3-star ratings are there. In market, it is the name is a True Light is there. Okay, and if you just see over the wrapper, you find that the consumption is 36 watt, whereas the lumen output is around 2400 lumens. So it is found that the consumption is same, whereas the lumen output has been increased. So it is the star rating. It is the difference between a non-labeled uh, lamp and labeled lamp. Now, what is the advantage? It is give more light. So, what is the advantage? The advantage is that if you are going to install some lamp, say 20 lamps are there. Now, only 16 lamps is sufficient to install in the hall. Suppose you have a small factory shed and you are going to design by a regular lamp is 20 numbers. But if you are using the energy efficient lamp, you can increase the distance between two lamp. You can increase the height of the lamp as per the application, even though you are going to find the proper lumen reaching at the floor. So when you are reducing the number of lamp, it will reduce the number of point to be prepared. It is in the wiring system. So out of 20 light fitting light points are there, only 16 points or 14 points is needed. So the installation cost get reduces. It reduces the maintenance, where you have to maintain 20 lamps, here we are going to maintain only 14 or 30 16 lamps are there. So if you are using the energy efficient labeled material, definitely it will reduce the number of say machineries or number of lamps to be used in the system. Okay, so this is the second method to do the DSM implementation. Third is the customer oriented program design. We have to make as per the customer need. Okay, so the meaning is that in this case, it is the it is included in the tariff also. Tariff is not same for all the type of consumer. The tariff is designed to suitable for every type of consumer, because every consumer need electrical energy in the different way. Application is different. In the residence, it is for as a livelihood, whereas in the industry it is used for the production purpose. So the cost is different for the commercial, for the residential, and for the industries. So our program, DSM implementation program, should be customer oriented. As per the customer should satisfy the demand. He should be happy. Customer should be happy to use the electrical energy, to use electrical gadget. So it is any programs, any policy for the DSM should be based on the which is win-win situation between different type of consumer and the utility. Next is the public-private sector partnership. So there is some partnership, the partnership in the technology, isn't it? Because small scale industry or small industry is not uh, in doing the energy conservation. We will see what is the why they are not ready to do the energy conservation program, isn't it? Some of the energy conservation program need fresh investment, so the people or the industry people are not ready to do the investment, so there should be some public and private partnership. The meaning is that the government should provide some soft loan, isn't it? If they are going to purchase some machinery from the other countries, the import duty should be smaller. Okay, the taxes should be smaller for the energy efficient equipments are there. So if we are having some proper partnership between the public sectors and the private sector, definitely it become easy to implement. For example, you want to install a solar plant, isn't it? Now solar panel is going to import from the other countries. Okay, so if the import duty is very high, the cost of the solar modules or solar panels become a very higher. Now the people are not ready to install because the fresh investment is very high. But if government and the private sector or the government provides some soft uh, corner to the import duty, definitely the cost of the import duty, cost of the PV model get decreases, isn't it? So you will find that even the present days, in the earlier days, there is no GST amount over the um, PV models. Only nowadays it is implemented 5%. Whereas you will find some of the electrical gadget or some of the things are there where the electricity, sorry, there is some GST is around 18%. So here the GST over the PV model is only 5%. So it is the partnership between the government agencies, or we can say that public private partnerships are there, and because of this one, the you are going to find a number of power plant, number of PV model power plant is going to install in the residential sector, commercial sector, agriculture. Agriculture is the best example. Government provide the soft loan, government provide some subsidy to install the solar pumps in the agriculture sector. So there are many advantage. It reduce the maximum demand over the power plant. It is independent of the distribution system. There is no problem of load sheddings, and farmer is happy to provide the proper irrigation water for the irrigation purposes, isn't it? And there is no uh, say environmental damage because of using a solar pumping system. So government provides some loan, government provides some subsidy over the solar panel, solar pumping systems are there, isn't it? And this is the way to implement the demand side management. So when one of most of the you it is found that every year more than 1 lakh agriculture pump is added in the system. So it will definitely, it is going to increase the demand of the power plant. And if the demand is increasing, we have to go for the expansion of the thermal plant and say hydropower plant, which is very costly, which already we have covered. So if you are shifting to the solar modules or solar pumping system, definitely it will help in implementation of demand side management. And our objective to demand side management is to avoid the additional generating facility in the system. Okay, so this is the case where we are going to we can implement the demand side management. So today we will stop here. Next time we will see the DSM implementation issues and barrier. What are the difficulties in doing the uh, this one? Thank you.